Hello. Yeah, so hello everybody. Good afternoon, everyone. It's really great to be here at droidcon London. And today our sharing topic is from ImageView to Compose, architecting the image loading the Compose way. And first, before the official starts, let me introduce us. So my name is Rui. Basically, we both are working at the TikTok, and I'm uh, more focused on building the fast and delightful mobile experience, but also spend most of the time making apps run smoother. And the rest of it, I love to hunting for good noodle spots around the world. Yeah, I'm the noodle ninjas. And here's my colleague Zeyu.
Hi everyone, I'm Zeyu. I'm a Android developer at TikTok social team. I'm a relatively newer Android developer, and I believe I'm one of the rare Compose native guy who is prefer to use Compose in basically all my features. So together we are pushing the usage and optimization of Jetpack Compose across our team and our business.
Okay, thank you, Zeyu. And next, take a quick review about today's agenda. So first, we will start at reviewing the design of the image view. I know everybody here must have much of the knowledge about it, but I think it's important for us today to help us introduce the real essential part we want to talk about in the Compose image. So after that, we will share some of the real-world lessons, like how we connected our existing image loader from the image view to Compose. And this part, like just in the third part, we will trying to create a bridge of the image loader for you to see how we could connect the existing image loader which built for the image view to Jetpack Compose. Okay, so let's start it from the first part, reviewing the design of the image view. So ImageView was building in the earlier Android days. I think the core responsibility of an ImageView is to hold a drawable and manage how it is displayed. Yeah, just that simple. And the framework follow the strict separation of concerns, which is views don't load data, they just draw whatever drawable you give them. So here is a very crucial design behind is the view, which is not supposed to do any the draw work, which should be fully described by the drawable. So let's skip to the usual view creation process and go straight to the core methods that's ImageView calls. So ImageView just provided a bunch of setters, but no matter what the setter formats, and no matter what the input parameters are, finally it will invoke the update drawable inside the image view. Yes, I believe everybody knows that. So the various resources setters provided by image view are essentially just a convenience method. So in the end, no matter what type of the resource is passed in, it will automatically be converted into a drawable object and held by the image view. During the updates drawable process, we can see that image view doesn't perform any direct draw itself. After the method is called, image view decides whether to invoke the request layouts and invalidates, depending on whether its size has changed. This is one example from the set. This code is the true example from the set image drawable. But the implementations of other methods are similar as well. So we can say no matter what you did, we always update the drawable and trying to compare the size of the image area, and if it changes, we just request layouts and call invalidates. I think this process is already tells some problem inside the image view. For example, the invalidates function invocation is always called what's the real change it is. So I think in the image view, the updates process, we actually have a very big granularity about the changes. No matter what changes inside, we only have one function to tell the view system to update the whole view in the onDraw callback function. So our attention finally lands on the onDraw function. As a method inherited from the view, we know that onDraw may be invoked repeatedly during the drawing process, depending on whether the view size has changed or if it has been marked as invalidated somewhere else. So in the onDraw function, here's a very simplified code, but we compare if the drawable value is changed or the size changed. And after all, we start to draw the drawable content on the canvas. So after reviewing the basics, let's take a look at the class hierarchy of the ImageView and its related components. In the invocation layer, we have the helpful function to set the image or the resources. It is where as a developer, we really pass in the resources through various setter calls, and also the image view system will provide the resource analyze layer. Internally, this layer processes and loads certain type of resource paths. However, in most cases, we rely on the third-party libraries like the synchronized loading resources from network, disk, or memory. Like we might use the glide, we might use the fresco to do these parts because the cache logic or the fetching image from the internet is more heavy than the local disk loading. And after that, we into the decode layer. In this layer, we usually will use the BMap factory, the image decoder to handle with the color space, sample, EXIF info, on sometimes the hardware BMap. And also we have the drawable layer. In the drawable layer here, just like we talked before, to handle the different type of the drawable, like the BMap drawable, the animated image drawable, vector, stylist, layer drawable. But no matter what it is, it have to be the class which have its internal states and also describe how the content will be drawn on the canvas. So that's also another very important point, that the drawable actually is a state-driven class, just like the whole image view. And in the view layer, we will handle the things that's not very related to the image or drawable itself, but very important to view system, like the scale time matrix, adjust view bounds, tint alpha padding. I believe most of us already handled many times on this function or the parameters. And finally, we will leverage the render layer to help us really make the content to be put in the canvas. So in the view system, I believe we are still using Skia, which is not in the Compose system. So from the canvas to Skia and to the render thread, display list, and finally we will do the composition to make all of this content to be visible in the screen. But this composition here is not related to the Jetpack Compose. It's just inside or behind the UI system. Okay, so after we talk about a lot of the good old days and all of this stuff we might handle many times, the next question is, what's the problem of the image view we used to have? So actually, it works very well in the past maybe 50 years or longer. But after we start leap forward to the straight state-driven UI development style, and after we look back with the comparison of what we did nowadays, there seems to be some critical thinking and reflection we could make on image view. So first thing is the separative concern. I think the image view has done too many data source type handler itself. Like we talked before, I think the most important things image view should to do is very simple. It just gets a drawable and decide how it to be displayed. So we can say all of the data source providers should be just a simple drawable. But when the daily using of during the daily using of the image view, I think most of us will handle the many different type of the data source and just set it to the image view directly. Like we use the drawable, of course, but we also have sometimes the resource ID. Sometimes it's bitmap straightforward or something else. So in terms of the separation of concerns, in essence, the image view have only one responsibility, but in many cases, developers don't work directly with drawables. Instead, they pass raw resource type to image view many times, in many ways. While supporting multi-data source type certainly makes the things more convenient for developers, that's true. But I think it also makes all this responsibility automatically absorbed by ImageView itself. So as a result, from a data source perspective, ImageView is no longer a single responsibility component. It's not that simple. Like if we take a look at the source code of ImageView, it also takes on the task of constructing the drawable. Yeah, the constructing of drawable, it's just be put into the image view itself. And another problem is the imperative loading. So I agree that the imperative loading is not the issue of image view itself. It's actually the whole view system's problem. Like at the first time when we're trying to switch from the view system to the Jetpack Compose system, it's always the first top 3 things we might need to mention now. But I think it does become a significant issue in image loading scenarios, especially. Because since an image loading library is, by nature, it's have to be a manager of a synchronized task straight pool, sort of. Because the image loading, like you load from the internet or from the disk, is always a time-consuming task, right? So every time when the image load like the image loading use case invariably has to deal with the lifecycle related events, like during your image loading, you have to deal with like destroy, unpause, or the page switch, things like that. You always need to ensure that the straight pool is managed safely, like you have the proper way to pose it or create it. Again, I believe it's not an issue of image view itself, but many problems will be more crucial or important in the image loading scenario. So we always spend more time on the image view just because of that. And last, we already talked about it a little bit before when we were reviewing the image view's design. The drawing in the image view, the drawing control in the image view, even we have the many of the check condition before we actually do the drawing stuff, I still think that the drawing is a one-shot task. It's a coarse granularity of the image we're drawing. So on-draw is the point where the image is actually drawn onto the canvas, but its management within image isn't very fine-grained. Both developers and the framework may call the invalidate function, right? And every time when we call the invalidate function, we're always trying to mark the area of the drawing as dirty. So the view system will try to redraw the content next time if it thinks it's necessary. Even it think it's necessary, but it cannot be very tiny granularity. It's always a very big task. We cannot figure out exactly which part is dirty or which part actually, which parameters actually could drive our UI system or the layer or canvas to be updated. So the mechanism doesn't tell us which specific factor truly warrant an updates. It's effective, I believe. Many times the developer could just call invalidate function without much thinking, but it's also not very precise. This thought means I believe we still have many of the problem in image view, but that's not the important focus things today. So just these 3. So after we know how many maybe problems we have before the good old days on image view, let's take an inside look at the design of Compose image. So first, let's just do a simple take a look at the function definition of Compose image. which also I'm pretty sure everybody's already very familiar with. But this parameter list here, I think it very clearly describes what it accepts. In addition to the standard modifier and alignment in Compose, it also takes a painter and content scale definition, alpha value for the transparency, and color filter. So from this params list, I think we could already learn a very important takeaway, which is the Compose image have the very strong separation of concerns in the very first design. So unlike the image view, which mixes all of the concerns because all of the image or display control logic and parameters is just located in the image view itself. In Compose, we delegate many things out of the image itself. For example, the painter is what to draw, and just like drawable, but it's cleaner. We will take a deep look at the painter later. And the content scale is just, I believe many people when they're starting to learning Android, the content scale is also a very important thing they learn from the image view. Like we described how the image will be cropped or scaled in the which axis. And alignment is just where to position with the bounds, but I believe alignment is more like the general Compose stuff. And also modifier. Modifier in this point looks very straightforward and common. We might think, okay, modifier is just what the Compose widget should have to describe its position, the size, things like that. But in the image, we will do a little bit the deep look at the modifier, and we will learn that maybe the modifier actually is the most crucial part in the Compose image. Okay, so whatever, let's talk about the painter first. So here's the abstract cases about the painter implementation we have in the Jetpack Compose. So the painter abstraction is a Compose answer to the Android's drawable system. It's designed for the measurement influence, like can it be affected by the composable size while the intrinsic size, which is very important, but we might want to take a look at it in this session. And also the drawing abstraction, like the multiple image source types unified in the painter. So in the Compose image, we actually don't care about like what the data source exactly is. I think it's a very big differences from the Compose to ImageView, because in the Compose image, we really don't need to care about the type of the data source. But in ImageView, like we talked about that before, ImageView actually have the many of the data source type handling logic inside an ImageView. And also it's very important, but it's very straightforward. It's a Compose native widget. So it works with Compose drawing primitives very well. And we could see that we also have the custom implementations, I believe, which is what we use mostly in the daily work life. And we also will try to custom a painter later in this session. Okay, and Compose provide many built-in parameter implementations which help developers quickly load and display images. And just like we talked before, the different data source is not be handled by image itself anymore. I think it's a very good practice of the separation of concerns. So you don't need to have to do everything in one class. Instead of, you could put the job into many separate classes to make your work more focusable and more clear. So under the hood, this part is very crucial, and this is also what we're gonna talk about when we talk about the modifier. Actually, the image is just a modifier paint. What that means, so if we take a look at the right side, it's actually a source code of image, but we do some simplify. We could see that first, we use the content description to create the semantics class, and we put it to the modifier. It's very important. We could talk about that later. And also, after that, we create a layout, and in the layouts area, there's a very important modifier called paint. And all of the parameters we pass into image actually will be passed into the paints as the part of the modifier chain. So from that, we could see that the image itself in the compose area is just like a box. It's not a real box, but it's just like box because it's very simple. It's just a container, a boundary. And inside that, the paint modifier will do the rest of the work, like decide how to draw content on the screen, like the size, alignment, alpha, color filter. So we could say that compose image is accessibility node through semantic modifier because, of course, we pass in the content description. And also it's a layout node with plain layout call. And also, very important, it's actually the builder of paint modifier. So paint is what we display an image really needs for. Image is essentially a convenience wrapper around modifier paint. Yeah, that is. So image in Compose is super simple compared to the image viewing view system. Image widget is just a convenience wrapper. And in this part, we take a look at the paint modifier. The paint modifier is responsible for scheduling layouts and drawing that would later dispatched to the painter. It holds states and manages invalidating when painters are generally stateless. And I think it's a very fine-grained residual control in the Compose plus painter. Because unlike, we already talked about that before, unlike the traditional view plus drawable system, where calling invalidates on the triggers is a full undraw pass for the entire view hierarchy. But Jetpack Compose performs fine-grained data-driven redraws when the painter or the parameters such as alpha, color filter, or image state changes. Compose selectively re-executed only the affected draw nodes, and it will skipping the major and layer when possible. So these declarative models allow partial, efficient, and isolated updates. Inside the redraw whole views, Compose redraws only one necessary, resulting in smoother animation, reduced overdraw, and better performance. So here's a quick example about the difference between the Compose and ImageView on the redraw parts. It's just a gradient painter, and we use the floating alpha value to change the progress, and the progress will finally change the color on the drawback function. And we create this painter, we launch effect, we use an animate function to change the progress to make the animate work. When painter progress changes, Compose internally track the draw modifier node on this painter. Essentially, the drawing node has become dirty, but it only redraws the painter's portion. It does not trigger the entire composition, nor does it rerun the major or layouts. So I think in this case, we could see the difference between the view system, which we use the invalidate to change the all undraw callback. Even you want to make it more precisely, you still need to create your own condition check in undraw implementation. But in Jetpack Compose, I think it's very straightforward. We only care about the value it changed and what it's affected. So the painter abstraction in Compose, just like we talked about before, is the answer to Andrew's drawable system. It's designed for the measurement influence, drawing abstraction, Compose native. But compared to the drawable, we could say that painter is more like a draw strategy, which could draw content at specific draw scope, just like we talked about that before in the modifier parts. But drawable is the whole drawable resource with states. But I think it's very important and also very funny. Many people in my daily life I talk with, they might believe painter don't have state. Like in our first feeling, we believe that most widgets in the Jetpack Compose should be stateless. But actually, painter has its own state. It's just Compose will actively try to recreate painter in many of the recomposition scenario to make sure the state won't affect its next composition. but we cannot strictly say Painter is not we cannot say Painter is a stateless widget. So let's back to the image composable API design philosophy. First is stateless and state-driven. Oh yeah, I just said the Painter is not the real stateless widget, but actually in the whole image composition process, we still could say it's stateless and state-driven. So we don't have the internal mutable states. Image doesn't hold decoding or loading states. It simply just renders the given Painter from the modifier process. And it's purely declarative. The design image is entirely determined by the parameters and composition states, then also by the Painter and content scale, etc. And state handled externally, like the loading, error, placeholder logic, and all of the dedicated to the higher level compositions, like the async image or the user-defined state holders. And also, the second part important is the enforced content description. I think it's a very big leap forward about the accessibility, because before when we use the traditional view systems, we don't have the very great awareness about how to support accessibility. But in the Jetpack Compose, I believe many people notice that in the many widgets, you always need to pass in the accessibility, like the content description string, and it's always attached semantic modifier. So in many cases, this node will be understandable not by the visible UI, right? So, and the last thing, like we talked about, is a separate of concerns. Separate concerns alignment for the clear and flexible layouts, and no matter if we take a look back at the Compose image, the Painter, the content scale, the alignments, and the modifier. These four widgets is very clear demo about why the Jetpack Compose image trying to do the separation for the concerns at the very first place. We basically just extract all of the implementations we used to have in the ImageView back days outside of it. So like we said in the demo, we could say the Compose image is a very simple structure. We could say it's basically just a box or a layout for the modifier. Okay, and after that, next session, our colleague Zeyu will share, guys, there's a case study about how we're bridging the Fresco to Compose. Why we bring up this topic is we talk about many guys from the big tech or the big product. Some people tell us, okay, we're trying to use Compose, but sometimes we already have the very big history legacy, which is built based on the ImageView and also the ImageView related the ImageView loading process. And we don't want to maintain like two different tool chains in the code base. So we're trying to figure out like how to migrate the existing ImageView and the related tool chains to the Compose world to make it easier for everybody to start and use the Jetpack Compose image. And of course, in this case, Zeyu will trying to bridge in the Fresco, which is, we are talking about the ImageView Fresco, which is based on the drawable system to the Compose. Thanks.
Hi, everyone. I'm Zeyu. Thank you. So, big shout out to Ray's clear and in-depth description of all the image and ImageView stuff. So, here's our case study. So, we already know that new libraries like Coil or some existing libraries like Glide are already providing Compose implementations. However, sometimes in our projects, it's hard to change our current image loading library. In which case, we still want to adopt Compose, but we can't rewrite everything at once. So here's a practice to how to bridge our existing image loading logic to Compose. Here we are using Fresco as an example because it is very famous and I assume everybody already know many things about it. So let's get started. So our strategy is pretty simple with all these like image loading libraries because if we have used Fresco, we might already know that Fresco in the final steps, it outputs drawables. And like Ray previously said, its equivalent in Compose is painters. So they inherently have something in common because drawable and painters, they all like required to provide like intrinsic size and provide some way to draw. Only like that drawables, they are stateful, and many painters, they are stateless, and their API signatures are totally different. And but anyway, we can find a way to bridge them. And also, one very important thing is the API design. How do we still maintain the full Fresco capability while still make our new like Fresco image composable, true to Compose, which means like expressive and easy to use, just like the original Compose image composable. So, so let's get it started step by step. So let's put the first thing most important is implementing a painter called Remember Fresco Image Painter. It's self-explanatory. It should be remembered as always, and it is use Fresco to load the image, and it is a painter to be able as a mediator to the Compose image world. So our first step would be build a Fresco hierarchy. Basically, we sometimes we want to load like a list of URLs. Many of them are like CDN fallbacks, and also images need like placeholder and error status images. So in Fresco, we can build a hierarchy to pass all the backup images and like error state images into it to build this hierarchy. It is totally out of the wheel system, and we need to create them in the Compose. And the next step would be create a drawee holder. Also, this is like has nothing to do with wheel. It's it doesn't need a wheel to be working. And drawee holder is to control and initiate resource loading. We'll talk about later about how we like abstract these image sources. It is like tied with like the API design. We can have many ways to like influence how we initiate the image request and how we control them. But generally the next step for the image painter is to create such drawee holder so that Fresco can receive our image resource and start loading, and then it will like at some time to like output some drawable that later we can use. So when our drawable is ready through drawee holder top level drawable, we can simply wrap it with a thing called drawable painter that is a custom implementation. And also, we should always like remember them, remember the holder, remember the hierarchy to make sure we always get the right drawable and remember this drawable to prevent from it like recreating. So this is the really important part of how do we implement a drawable painter to fully bridge the drawable with painter. We just said drawable and painter, they have a lot in common, but they also have some like concept differences. But let's first focus on the most important part, drawing. So this is what it's like to have a painter that is holding a drawable and it can be drawn on the painter's canvas. It's really straightforward because all drawable needs is to first set a bound and then draw on a Android canvas. Because Compose is multi-platform in Android, we just call native canvas to convert it to Android canvas. And also there are some Fresco-specific implementations, like if it is a root drawable, we should not draw It is Fresco specific. If you want to bridge out other like image loading libraries, maybe you should do that accordingly. But however, drawable is generally stateful, which means we need to have some little tweaks on our painter to make it fully compatible with drawable. So basically, we can set a callback to the drawable to get notifications when it's invalidated. That's the most important, but it has also has other like interfaces we are not talking here. The basic idea of how we listen the invalidation of drawback and also make painter aware of that is by setting such drawable. And this drawable, setting this callback is basically we can add the drawable painter as a remember observer. When the painter is remembered, we can add the callback, and when the painter is like abandoned or like not remembered in general, we ditch that callback. So when the callback arrives, we can actually set flags, flag states in the painter itself, and the Compose runtime will record the reading of these states, and like Ray just said, restart the during the draw phase. So basically, we can make the painter reactive to the invalidation next on draw arrived, but it doesn't affect composition because this state is held within the painter itself. It doesn't appear in any composable function. So the recomposition root is not in the composable. The compose runtime will only check if we have read this and the value changed during the draw phase. And also we need to find a place to read our newly created flag state. And a perfect place for it is in onDraw. It's and the diffing system of Compose just makes sure if our invalidate tick is the same, it will not invoke a redraw of the painter. So it is very efficient, and it is fully compatible with drawable through Compose Painter. And here's our final Fresco Image Painter API. There are several parameters which is very unique. It is designed to enable the full final image composable. We will talk about later. Actually, it is right now. So before we talked about our image source abstraction, there are a whole lot of ways to do that. This is just our one approach. So basically, we have a sealed interface of Fresco image source that is, so later we can easily enumerate them through a one branch. And we have defined several data classes of this Fresco image source that holds only necessary data we need for each image source. And then in the Fresco image painter, we can identify which kind of source it is and load them accordingly. That is done by Fresco. So the next big step is we want to maintain the full power of Fresco, so we can actually expose these necessary configurations out as some lambdas. During building Fresco image, we can have like the ImageRequest builder and like Droid controller builder and Droid hierarchy, and expose them to the Compose interface so that within the scope of these lambda, we can access the object and set whatever properties we want. For example, in the ImageRequest builder, we can get the builder and set it to decode progressive JPEG. And finally, we in many cases in our business, we set image loading listeners to the image loader itself and image view. And we can also support the functionality in the compose, although it is like, I don't think it is like fully conform to the compose philosophy, but there's real needs and we can add them. So this is the full API of our Fresco image. Yeah. Next, I will get back to Ray to finally say thank you for listening. Yeah.
Yeah, for our both. Thank you, everybody. Last and very important thing is our friends have another sharing just near this floor. It's in the direct domain. They will talk about how to debug in the real-world training and many practical guides to the Compose performance, which something I think is pitfall, but also very crucial and good to know. So thanks, everybody. And if you have a chance, welcome to the next session just near here. Thank you, everybody.
Thank you.